Okay, I've done P5-16 before, and I want to kind of take a different path on the text since have a group that is interested in CNC. We're going to look for a simple stick font or something of the like. So I'm going to fly Kindle out of the way, and I did a search for simplex font. You could also do a search for stick font. And the simplex font, if you have AutoCAD installed, is probably going to be an SHX. So the HXS fonts go directly um, into AutoCAD. And I had pretty good luck with the W fonts. I'm not really recommending any one over the other. They all have the ad-based revenue thing going on. So make sure that any of these you are reading through and finding the actual place to download instead of the bloatware. So we come down a little ways. Let's see, that was through the start, through the continue. I want to download the font. I tried this once before, so it's actually a repeat. It came up with a splash screen and I just canceled out of that, X'd out of it, and it allowed it to complete the download. All right, so any of these that you download, you will probably want to run a scan on. So if you have Windows Defender or, well, one of those, um, or any of the major virus scans, should be able to right click and just do a quick scan. All right, so before I even open it, we'll let it scan now. Doesn't find anything. Oh, I guess it would let it run my. Oh, didn't realize I had that many in my. So we'll let that go. Pretty much can go to show more options, and I'm going to 7-zip. And since I'm not sure what all is in this folder, I want to make sure to extract it, and then we'll take a look. So the simplex TTF is the true type font. It should, see if there's um, any preview. So that looks pretty good. The main thing is that whatever stick font, when I did the search, Go Engineers and SolidWorks had an OLF Sans. I previously downloaded that, and we'll probably do that as a comparison. But the simplex is pretty straightforward. The OLF Sans, wherever I found it at. If you, I thought maybe that when SolidWorks installed the SolidWorks CAM, it would do the CamWorks font, which is also a stick font and works really well. When I was using CamWorks all the time, that was my go-to. So what we need to do is let's just go ahead and copy that. All right, and make sure you're doing this out of the extracted folder, not the zip folder. The zip folder is going to be a temporary, and then and it's probably not gonna like it very well. So if we do a search, let's see, probably need to be in C drive. It's going to be in Windows somewhere, but if I go do a search for the fonts folder, and then we're just going to paste. All right, so installing Simplex 1 of 1 fonts. Now that should be available. I'm going to scroll down a little ways. And just a quick check. Now a lot of these will look, so there's my Simplex regular. So a lot of these will look like single point fonts, but in reality, if it makes 2 trips around the text, so scanned, yeah, I think it's trying to scan the whole thing. Anyway, when I ran it before, I did not have any issues with it. So let's go ahead and close the fonts. And I'm going to kind of back out of some of these. All right. And We'll get the Kindle back up. So when we're dealing with the fonts, um, I don't want to go all the way around, all the way around. And then also saw a couple that would be of interest if you were doing a plasma, a laser, something that you wanted to stay connected. So it would have little tabs that would connect the O, the center of the O to the and the center of the D, so it doesn't drop out and just become an open pocket. All right, so I think I've got myself prepared for a couple, and for this project you can use just about any font that you're interested in. Just keep in mind they're calling this out as a deboss, which is going to go into the part, and emboss comes out. And if we're doing a a chamfer engraving tool, it's going to be probably along the lines of a 90-degree spot drill. I've also used center drills like an odd or a number one center drill, anything with a point. And then if grinder is available, I've also ground the tips on an old tap or old end mill that uh, was able to generate the geometry. All right, so we get into actually drawing, and I look at this. We could draw this from the front and then remove this material from the side. If we drawed it from the top, we could cut down through. And typically when I look at these, I find the L shape. And this is a 10 by 8. I think in previous videos that I did, I made this a thin feature and it kind of confused things making this 10 millimeters. It's not that it really hurt anything, but with a thin feature, it has to be, or it wants to be, um, the same thickness all the way around. So we'll just mention the thin feature this time and come back to it later. All right, so I'm going to pick up my new, and this is going to be a part in metric. And I want it to kind of mimic the views. So keep in mind when we're creating the drawing, front view, top view, right view. And so if I draw this on the right view, and I could go mid-plane, which would put the right plane right at the center. I could put it off of either end. It's not really going to matter at this point. So on the right plane, and I'll put the corner at the origin. All right, so I just wanted to mention the um, the thin feature. And if I remember this correctly, we had the 8 millimeters on the thickness, and then the radius is 10 millimeters. And if we went height-wise, looks like we're missing a dimension. So, you're the designer, you pick one. So if I said that this is 8, the radius is 3, that's going to give me 11. Oh, the diameter was 10, that's 12. So we're up to 20. Oh, here I go doing math. 23, and if we were to say 17 in between, that would give me an overall height of 40 millimeters. All right, so we're going to have to verify that number, but just kind of running through the thought processes. All right, the bottom is 30, but I don't think 30 is gonna work out as well. So if I do my fingertip to fingertip scale, it's about the same, but not really. So I would rather draw this a little big, see if there's interferences coming around, and then make adjustments as needed. All right, so let's take a look at this from the thin feature because it's open. If I wanted the size to be the same, let's go mid-plane, and our overall was the 160. And it's to the outside. I've drawn the outside and it is going to the outside, so I need to make it an interior. All right, but the problem is going to be that it's 10 millimeters on the thickness, and I can adjust this one to 8. So pretty much going to have to kick that out. We'll go back and jump into the right plane. So I'm using my control 1 through 4 to figure out which one I need, but I know it's top, front, back, left, right, and then top, bottom. So control 4 will put me back into the right plane. For the sketch, we could try the offset, but I think the offset's going to do the same thing. We're going to have one side be not correct or incorrect. That I'll just go ahead and draw those in. We'll put the 10 millimeters on the top, the 8 millimeters on the bottom. And now it looks like that's a little bit on the large side, so let's just bring it back to 35. 30? All right. Nah. Okay, we're going to go with one of those. All right, so I'm still not sure what that one is doing. We'll go mid-plane. We have the 160, and we'll go ahead and accept the sketch. All right, so next we have a pattern. And the holes on the front that one looks pretty well at the sharing concentric to the radius. That one looks like it's about 2 millimeters down. So that one's really going to drive the height as far as having to do the unthinkable and scale our drawing to come up with a number. So let's go into the pattern first, and I'll do this as a sketch pattern, and then I'll go back and do it as a feature pattern. So as a sketch pattern, I would be interested in setting this up. We have our another missing dimension. All right, so let's go and see what 8 millimeters looks like. It is 7.96 from the edge and 19.4 from the back. So even though I'm technically picking the back top edge, because it's a projection, it will figure out where it intersects across that line. Kind of in a sense like the Pierce does. It says it knows that there's a solution. We're parallel to this edge or the bottom edge, so it will go ahead and calculate it. All right, my linear sketch pattern then is 7 by 20, and that means that we have 1, 2, 3, 4, 5, 6, 7, 8 holes. Now, depending on the software, let's go back into that. Depending on the software, let's go ahead and pick the x-axis. It's given us 20 millimeters on the spacing. And if I tell it to dimension the x spacing, that has a better chance of going fully defined. One of the issues with the linear sketch pattern is it often doesn't go defined, and you have to add a relation or a dimension to get it to that point. All right, so if I hit tab and I don't see any preview, well, let's keep scrolling, and I have not selected the entity to pattern. All right, so that's going the wrong way. We scroll back up, reverse the direction, and then we see what we get. All right, so that goes fully defined. It's going to insert a center line, a construction line, and set it to horizontal, or at least some part of it, coincident, and to the side. So I don't think it's going to act like if it moved and it acted like a convert entities, then I would be a little more concerned with it. So let's go ahead and extrude cut, and this is going to be an up to next, which is fine. All right, so that is going to be the linear sketch pattern. I'm going to suppress that and go in, and you can choose either way to work with this. And let's see, so we can tell the difference. This one will be 10. We had the 7.96, and then we have the 19.4 off the back edge. And in this case, we go ahead and complete the extrude cut when it stayed with up to next. And at this point, I'm going to go looking for my linear feature pattern. All right, so since that one is pre-selected, the cut extrude was pre-selected, then I will end up with 20 millimeters. The spacing is the edge, along that edge direction. We have a total of 8. And I think I started to say, but I'll say it again, is that depending on the software you're using, you will have to determine, is it going to by the spaces, in which case it would be 7 spaces, or we have 8 instances of the feature. So there is my features and faces. And if it failed, then I would try the geometry pattern. But this is fairly simple, so I'm not expecting. If it gets more complex, there are places where we have issues. So I do want to try a measure here. So we had the 7.96. It goes to 12.04 on that end from the center to the edge. So it's not centered. Is kind of where I would go with that. So my habit is to put all of the geometry in and then worry about the radiuses later, especially since we have a radius of 12 in 2 places, and well, we're going to go with the 12 on the top, but I'm not entirely sure about that one either. All right, so we can figure this out as we go. So 10, and I'm going to Control Select and make those equal. And from the radius, so that looks like it's at about the bottom, and will also be about 12 down and 12 in, so it lines up concentric. And then this one I would still say is 12, but let's see what 14 looks like. All right, so it's a little bit lower, maybe quite a bit lower. And we'll go ahead with the extrude cut. And it can stay up to next since we picked that. All right, so just looking at this, there is an offset. Maybe that's 13. Maybe we still need to inspect it. So it's one of those, when we get to the drawing, we'll take a look at that geometry and highlight it for review. All right, so that whole thing with the fonts. We're going to open up a sketch, and if I just go directly into the font and have not drawn a curve, then I'm going to have to rough position this. The curve is a line or a spline or an arc, and I'm going to do something, let's make it all caps so that, and we'll put in Mesa Community College. All right, so my font then is, I need to go find the simplex. So if I type in the S, and we find the simplex, and the units are, let's start with 8 millimeters, and hit OK. All right, so I'm going to have to move that around a little bit, and now that I have a size, let's go to 4 millimeters. And that was a little bit big, and you can kind of see that rough positioning it can be a challenge. So what I want to do is, and what I normally do first, is we'll find a center line. And I want this centered, so we'll just worry about the height. So if you wanted to put your name in there, if you want to put your company, go ahead and just experiment with what the text looks like and the results that you would get. So 16 looks close to my selection. I go back and double click, I find the curve. It's going to justify to the left. I'm going to center it. And now if I go into the font, we did 4. Let's see what 6 looks like. Right edge to edge. Maybe 5.5. All right, so something along those lines. And when I scroll up on this, the simplex still has a back and forth. So I may have to go find the Olaf. So we will see if that actually produces the cam. All right, so if you did not find a stick font, like apparently I did not, then feel free to pick any of these. Actually, I was kind of jumped. Oh, was still searching for us. Let's go with an Arial and hit OK. All right, so on the TrueType fonts, you can definitely see this is going to spin it around twice. We'll probably have a little bit of overlap, so I want to increase the spacing by 120. So even if I'm going through what I probably would not do, and it depends on the CAM program as well, I would not try to pocket these out with a really small end mill. It takes quite a bit of time, and with a single point, we're just scratching those into the to the geometry, scratching that text into the face anyway. All right, so if this is actually single point, I'm going to accept it and call it done. All right, I don't want the geometry. And if we go ahead and emboss it because we're going to 3D print it and see how it turns out, then I'm going to be in an extrude boss base and not a midplane. We'll probably go blind. Let's make it like 1 millimeter. All right, and the boss is going to be raised text. So maybe not that much. Let's go 2 millimeters so you can see it. The downside to this is all of these sharps, the end mill would have to go through and pick those out. A lot of geometry, a lot of time, and that's small. Even with the radius, that small of of gaps in geometry, well, that would be an issue. All right, so I can delete that and delete the feature and go back to a cut extrude. And at the very beginning, I told you to turn off the instant 3D. Well, the instant 3D is actually kind of useful here if I have not fully defined this, but there's a grip on the 2 millimeter. And if I drag it into the geometry, we'll be able to see that it switches from a boss to a cut. All right, and then when I double click again, let's go ahead and just make that like, let's make it 1 millimeter, because even that's going to be pretty deep if we tell it to try to find that geometry. All right, so the problem that I have with Instant 3D is if you're not expecting it or working with it, every one of these can get moved or drug accidentally, and that is a problem. So keep the Instant 3D off unless you are, oh yeah, and it probably would be a good idea to go ahead and save that. So my new folder for assignment 8, the crank assembly, don't remember exactly what we called this, and this is the base. All right, so we're going to go through a little bit more on our geometry, but we have a base for the title, our part number, and a material of 2024 aluminum. Not a very common aluminum, so we'll also talk about material selection and going through some of those choices. All right, so it's okay that that's underdefined. The curve is pretty much driving the position, but text has a tendency to not go fully defined. All right, so let's put in the big fillets as 12 millimeters. So not by 1 millimeter increments, so hitting the arrow doesn't help. 12 millimeters as the preview, and then we'll go in and put in the 3 millimeters. Maybe. Uh-oh. Okay, so I paused it real quick just in case it was trying to crash on me. So let's see what 3 millimeters looks like. It's pretty close. But yeah, I'm thinking maybe I got a little carried away with the 10 millimeters. So we're just going to go back to the cut extrude, find that dimension. The 8 millimeters was probably better, but let's see what 6 looks like. And we're just going to go through this process. Now, this kind of leads into what we really do in mechanical design is there isn't a nice drawing in most cases. We built the previous part, we're going to build the next part. We're going to go through this process and make a bunch of decisions. And if it doesn't look right or doesn't feel right, you just change it. All right, so if I rebuild, make sure that you rebuild because that geometry is going to remain until we get to a point. All right, so I'm probably going to go hunt down my other single point fonts so I can do this again. And I want to actually run this through some of the CAM programs as an optional. So I do want to show the difference between the single point and the simplex would probably be okay as close as it is, but if it's going to pull up a burr or take longer to machine, then it really hasn't it hasn't saved me anything. So all right, so we have some other issues to resolve and some dimensions to check, but that looks like we're pretty good on the base.